Okay, my friends, it is time for Venn diagrams. Very exciting times ahead. So, first thing I should say is that these regions that are created by these circles, and by the way, you should always draw these circles exactly in this format with two at the bottom, one on top. There's actually labels for these regions, and here they are, 1 through 8. We typically won't be using region 8 in this class, but it is important to know that it does exist. Okay. Steps for the Venn diagram test of validity. Number 1, abbreviate. Abbreviate the argument, replacing each category with a single capital letter. For this example, I'm going to use an argument that we've already covered. We already know it's valid, but it's already in standard form for us, so we get to skip a couple of steps here. Okay, what we have to do now though is replace monotremes and things that lay eggs and all those things with just a single capital letter. Very simple, like this. Done. Number 2, draw and label. Label the circles with capital letters using the minor term, the subject term of the conclusion, for the lower left circle, the major term, the predicate term of the conclusion, for the lower right circle, and the middle term, the remaining class on the middle circle. That is a very exhaustive way of saying you just take the categories of the conclusion, E and T, and you just copy and paste them there at the bottom. That's all that means. The other term, the middle term, that goes up there. Simple enough. Done. Number 3, decide on order. Note, if the argument contains a universal premise, enter its information first. If the argument contains 2 universal premises or 2 particular premises, order doesn't matter. In this case, we actually have 2 universal premises, both A-type sentences, so we don't have to do anything. In the next example, this will matter, so we'll skip that for now. 4, enter premise information. Universal statements get shaded, particular statements get an X. So, what does this mean? Well, what we have to do is shade regions of these logical spaces that simply don't exist. For example, premise 1, all MRT, what that's really saying is that there is no M in existence that isn't in the T region. That means region 1 and 2, there's nothing in there. As you can see, once we've shaded this region, the only logical space left within the M category overlaps with the T category. That's what we mean when we say all M or T. The same thing goes for all ERM. Those 2 regions are now no longer in existence. As it turns out, the only region of E that exists is all completely inside of T. Okay. This is a good time to tell you what universal negatives look like. So whereas universal affirmatives are kind of like a moon shape, universal negatives are more football shape. That's how you diagram no M or T. This here now is a long explanation as to how and where to put the X's. Instead of reading this for you, I'm going to go ahead and tell you what this really comes down to. If you have a diagram like this and you want to diagram some E or M, this is not at all how you do it. You see there region 3 and 4, that is a non-existent logical space. There's nothing in region 3 and 4. So by placing that X half in region 2, half in region 3, we're making a mistake. That's just not how it goes. How would you diagram some ERM? Like this. Step 5. Remember to decide if you are taking the hypothetical viewpoint or the Aristotelian viewpoint. Now, in that note there, you can read, there are some guidelines for how to do this, but I want to summarize this in the following way. Basically, you want to go to each of the categories, M, E, and T, and decide if you are assuming these things exist. As it turns out, monotremes and all the other things we're talking about actually do exist. So we do have to diagram X's for these categories. So what we're going to do is we're going to go in order: subjects, predicates, and then until we're done. Okay, so let's begin with M, the subject of premise 1. We need to place an X somewhere in this diagram representing that M's actually exist. The only logical space of M's that could exist is actually in region 3 and 4. So where do we put that X? We actually don't know if they are M's that are T's and M's that are E's. We're not clear. So this is the case where we actually have to place it, as I said earlier, straddling it. So that's actually the appropriate placement of this here M. Okay, let's move on to the subject class of the second premise, E. Well, that X that's already diagrammed on there, it doesn't actually unambiguously state that an E exists. That X as it is, it could be an E, it's definitely an M, but it could either be M and not E or M and E. So what we need to do here is give this category its own X. That is unambiguously an E, and that's actually the only logical space that E's can exist in. Okay, now at this point I have to warn people get really crazy with X's. Typically 2, maybe 3 is the only amount of X's you'll ever actually need. So for example, in this diagram right here, we actually already have an X representing each of the categories. There is an X for M, it's right there. There is an X for E, it's right in the third region. And there's actually 2 X's for T. Make sure you can see that. T is already well represented in this diagram. There are 2 T's in there. So you don't need any more X's. That's it. We have at least 1 X per category. Step 6. Assess for validity. A categorical syllogism is valid if, by diagramming only the premises, we have also diagrammed the information found in the conclusion. This should sound very familiar. It's much like the way assessing for validity using the square of opposition works. So let me say one word of caution here. If no X or shading appears in an area, this does not say that nothing exists in the area. Rather, it indicates that nothing is known of the area. Again, it only means we have no information about the area. Thus, for all we know, the area might be empty, or it might contain one or more things. Okay, so here is our diagram so far. Here's the question. Can we find the conclusion already diagrammed here? Is it the case that all E are T? Well, every single E that is in existence is confined to this logical space right here. It's all in region 3. And notice that the entirety of region 3 is contained by the T category. This means that in fact, every single E per this diagram is contained within the T. Yes, that means that all E are T, which means this argument is valid. Excellent. Oh, what fun. Now, there are 2 more steps that I need to stress here, because when maybe going over tests or sometimes even homework, people forget to label these arguments valid or invalid. So one more thing I'll say here is label the argument valid or invalid. Do not forget to do possibly the most important step, basically, to show that you've understood what's going on here. And I'd recommend, of course, looking over your work and making sure that you didn't skip any steps or making any silly mistakes. Okay, excellent. Let's do one more example, and then I think I'll let you do some practice problems. Here is the other argument that we've already assessed, so we are already sure that it's valid. Nonetheless, I think it's a good idea to check this out and see if we can reproduce this with a Venn diagram. Okay, let's first of all get rid of all these long category names and replace them with simple capital letters, like that. Now what we do is label and decide on order. In this case, it actually does matter. As I said before, you want to diagram universal premises first and then particular premises. So if you have an all or a no statement, an A or E type sentence, do that one first. I always do something like box it to remind myself I have to start there. Okay, now that we've done that, diagramming it is easy enough. Just shade in region 3 and 4, and now no A or F. Now we have to diagram some FRC. Okay. There is actually only one region, region 2, where F and C intersect. There's only one place where you could possibly put that X, right there. Okay. So if we want to now, we can actually see that we need one more X on here, at least, and that is to show that A's exist. We already have one X showing that F and C, that same X is showing that both F's and C's exist. We need an X for the A region. There's actually two logical spaces where A's could exist, so I'm going to straddle that line right there. Okay, now what we do is, if you are writing this out or do your own problems, at this point I recommend people put down the writing utensils. Do not try to diagram the conclusion. It should already be there if it's valid. So is it the case that some C are not A? Well, that right there is a C. It is within the C category, and it's outside the A category. What does this mean? Once again, my friends, this argument is valid. Okay. You have lots of work ahead of you. I'll let you go ahead and have some fun, and maybe you'll dream of circles.